First of all, what you need to know is that the differentiation of sin x is cos x, right? The first one, the first result that I have given here, differentiation of sin x is cos x, right? And if you have the differentiation of sine of any linear polynomial, you see sine 2x plus 3. If you have to differentiate sine 2x plus 3, then first of all, you will write differentiation of sine as cos 2x plus 3. That is, this entire thing you have to write as it is. And then you need, after writing the differentiation of sine as cos, you now need to multiply this by, you now need to multiply cos by the coefficient of x, which is 2, right? Similarly, here, if you see differentiation of sine 1 minus x is cos 1 minus x, because differentiation of sine x is cos x, and you need to multiply this by the coefficient of x, which is minus 1. So we are getting here minus cos 1 minus x, right? Similarly, if you see, you have differentiation of cos x. Remember, differentiation of cos x is minus sine x. And if you have cos of any linear polynomial, cos 1 minus 2x, then you will differentiate cos first, write it as minus sine of 1 minus 2x. And then you need to multiply this by the coefficient of x, which is minus 2, right? Okay. So this is how you are going to differentiate. And next result was differentiation of tan x is sec square x, right? Suppose if I want to differentiate tan 1 minus 4x, again tan of a linear function, linear polynomial. So therefore, first I'm going to differentiate tan, write it as sec square 1 minus 4x, and then multiply this by the coefficient of x, which is minus 4, right? Okay, now look at this next result. ddx of sec x, differentiation of sec x is sec x tan x. Okay, all these needs to be memorized. So if I want to differentiate sec 2x minus 1, how am I going to differentiate? First, I am going to differentiate sec and write it as sec 2x minus 1 into tan 2x minus 1. And then you are going to multiply this by the coefficient of x, which is 2. Okay, this coefficient here. Fine. Next, ddx cosec x is minus cosec x cot x, this result. Okay, if I want to differentiate ddx cosec 1 minus 5x, how am I going to differentiate this? First of all, I'll differentiate cosec, write it as minus cosec 1 minus 5x into cot 1 minus 5x. Right? And then you need to multiply this whole thing by the coefficient of x. And what is the coefficient of x here? Minus 5. So this result, ultimately you will get 5 cosec 1 minus 5x into cot 1 minus 5x. Right? Next, ddx cot x is minus cosec square x, this result. Suppose if you have to differentiate ddx, let's say you need to differentiate cot x by 2. Again, x by 2 is also a linear polynomial, isn't it? Because the power of x is 1. So how will you differentiate this? First of all, observe that cot x by 2 can also be written as ddx cot half into x, right? Now, if you want to differentiate this, first you write this as minus cosec square x by 2, right? And then you need to multiply this by the coefficient of x. Here the coefficient is half. So your answer is minus half cosec square x by 2. Clear?
Yes, sir.
Okay. So once we know all these are the results that you need to know, whatever is enlisted here. Okay. And now we start with some problems. Not many. There are only 4 problems I have given here. You just need to start with. You just need to know the results first. You need to be thorough with the results. The deep differentiation actually is in detail in class 12, not in detail in class 11. Class 11 only has an introduction to differentiation. Okay, let's do the first one. Given function is root x cosec 5x plus 7. Okay, now see, this is a product of two functions. If you take this as u and you can take this as v, right? And then you can differentiate by u into v root. So therefore dy dx will be equal to ddx root x cosec 5x plus 7. Now we have chosen our u and we have chosen our v. Not that there's a hard and fast rule that this is the only one you have to choose u. You can take the second one as also u, as long as your order of differentiation is correct. Okay. So you have first function here u into ddx of v, which is cosec 5x plus 7, and then plus cosec 5x plus 7 into ddx of root x, right? Better still, what you can do is you can in this step only you can, because you have to differentiate root, you can write this as x to the power of half cosec 5x plus 7, right? And then here you can write x to the power of half here, you can write x to the power of half, and here also x to the power of half, instead of writing root x, right? So that it becomes easier to differentiate. So now we have x to the power of half and cosec ddx cosec 5x plus 7. If you see the derivative of cosec, what is the derivative of cosec here? Derivative of cosec is minus cosec cot, right? So you need to write here, and because you have the coefficient of x as 5, so 5 cosec 5x plus 7 into cot 5x plus 7, right? That was the derivative of cosec cot, and you also have a negative sign. So ddx of cosec is minus cosec cots. That is why you have a minus sign, and you multiply it by the coefficient of x, right? Plus, and ddx x to the power of half. Just one small note that I would like to make here is that whenever you are multiplying, suppose you have let me do this and then I can show you. See, cosec 5x plus 7, and you are multiplying it by what? You are multiplying it by x to the power of differentiation of x to the power of half. See, if you write this here, okay, sometimes it is also confused as multiplying this by half x to the power of half minus 1, right? So therefore, whenever you are multiplying a trigonometric function by a variable or a constant, try to write it in the beginning. Okay. So instead of writing later, so that you do not get the impression that you are multiplying the angle only. Okay. You're multiplying the entire trigonometric function, not the angle. Okay. Cosec 5x plus 7. You understand what I mean?
Yes, sir.
Okay. Okay. Now we just simplify this a little. So you have minus 5 x to the power of half. You can write this back as root x cosec 5x plus 7 cot 5x plus 7, and you have plus half x to the power of minus half cosec 5x plus 7. So this is minus 5 root x cosec 5x plus 7 into cot 5x plus 7, and half x to the power of minus half can be written as 1 by 2x to the power of half, isn't it? And what is the x to the power of half? It is root x, right? So let me write
Yes,
this
sir.
as root x. Instead of doing one more step, I've written it directly. Okay, cosec 5x plus 7. Now what you can do here is that you can take um, 1 by 2 root x, just to write it in a, because your differentiation is complete here, or even here also it's complete. Okay. So what you just need to do here is that you need to express your answer in a better manner. So I take 1 by 2 root x cosec 5x plus 7 common, right? And I multiply this by 1 minus, because I'm taking 1 minus 2 root x cosec 5x plus 7 common. So that is why I'm getting 1 here. Okay. Minus, and you are getting 5 root x into 2 root x cot 5x plus 7, right? If I take 1 by 2 root x cosec 5x plus 7 common. So now if you
Yes, sir.
simplify this, you will get 1 minus 10x cot 5x plus 7. And that should be your answer to express it in a proper manner. Okay. So can I continue with the next problem?
Yes, sir.
Yeah. The next problem here is sine 3x by x minus 6. So I assume that y is equal to sine 3x by x minus 6. We want to differentiate this. So therefore, we are going to use here u by v rule. If I take the numerator as u and the denominator as v, you can use the u by v. Okay. So if I take u as sine 3x and v as x minus 6, therefore dy dx will be equal to d dx sine 3x divided by x minus 6. Now you have u by v. So first function v into d dx of u, which is sine 3x, minus u sine 3x into the d dx of v, which is x minus 6, divided by x minus 6 square, v square, right? So now you have x minus 6 into d dx sine 3x. You know the derivative of sine is cos, right? So you write cos 3x. Not only that, you also have a linear function, right? Linear polynomial inside the sine. So that means you need to multiply this by the coefficient of x, which is 3 cos 3x. Clear with the differentiation?
Yes, sir.
Minus sine 3x. The difference, sine 3x into differentiation of x minus 6. What is the differentiation of a linear polynomial? It is 1. So sine 3x into 1 will simply give you sine 3x divided by x minus 6 square, right? So now what are we going to do? We are going to write this in a proper manner. Thrice um, x minus 6 cos 3x, right? Minus sine 3x divided by x minus 6 whole square. Now there is nothing to simplify here. Okay. So you can leave your answer at this only. Okay. This is actually a
Okay, sir.
proper manner of expressing, because we already have a cos 3x separately and we have a sine 3x separately. So this answer has been expressed in a proper manner. Okay. Moving on to the next question. 1, 3. Function here is tan x by 2x plus 3. Again, use the u by v rule. dy dx is d dx tan x by 2x plus 3. U here is tan x and v here is 2x plus 3. So v into d dx of u which is tan x, minus u, which is tan x, into d dx of v, which is 2x plus 3, divided by square of the denominator, 2x plus 3 square, right? So now we are going to differentiate this 2x plus 3 writing as it is, and d dx tan x, if you have memorized, d dx tan x is sec square x, right? Minus tan x into d dx of 2x plus 3, d dx of a linear polynomial is nothing but the coefficient of x into 2, divided by 2x plus 3 square, right? And that should give you your answer. Just write this in a proper manner. 2x plus 3 sec square x minus 2 tan x divided by 2x plus 3 square, right? That should be your answer. So I'll proceed with the last question. Question here is y is equal to given function sec ax minus b divided by x square minus 2. Again, we are going to use the u by v rule here, considering u as the numerator and v as the denominator. Sec ax minus b divided by x square minus 2. So v here is the denominator, x square minus 2 into du dx, which is d dx of sec ax minus b, okay, minus u here is sec ax minus b into the d dx of v, which is x square minus 2, whole divided by the square of the denominator, right? Now we are going to differentiate. In the numerator, you have x square minus 2 and d dx sec ax minus b. If you know that d dx of sec x is sec x tan x, right? And not only that, but multiplied by the derivative of multiplied by the coefficient of um, x, right? So you have a into sec ax minus b into tan ax minus b, right? Clear with the differentiation?
Yes, sir.
And here you have sec ax minus b into, and d dx x square minus 2, you distribute this over x square minus d dx 2, and you divide this entire thing again by x square minus 2 whole square, right? So you have here a times x square minus 2 sec ax minus b into tan ax minus b minus, and what do you have here? You're getting a 2x, right? d dx of x square minus 0. So you simply have a 2x sec ax minus b whole divided by x square minus 2 whole square. Okay, now we should be able to simplify this a little. Okay, write an answer in a proper manner. So you have ax square sec, because if I see I have a sec ax minus b here also, and I have a sec ax minus b here also. So let me just simplify this a little. So ax square sec ax minus b into x square minus 2a, in fact, x square minus 2a sec ax minus b into tan ax minus b minus 2x sec ax minus b divided by x square minus 2 square. Next, You can multiply ax square into sec ax minus b tan ax minus b, right? Minus 2a sec ax minus b into tan ax minus b, right? Minus 2x sec ax minus b, and this entire thing divided by x square minus 2 squares. Now, because you have sec ax minus b throughout, you can take sec ax minus b common. Okay. So if you take sec ax minus b common, what are you left with? You are left with ax square tan ax minus b minus 2a tan ax minus b minus 2x whole divided by x square minus 2 square. Okay. But the proper manner of writing is, as I told you, whenever you're multiplying something by a trigonometric function, always try to write this in the beginning. So you can write this in the beginning, x square tan ax minus b. This is not a question of being mathematically right or wrong, but this is a question of propriety. Sec ax minus b, right? Divided by x square minus 2 square. And that is your answer. Okay. So this exercise is over. Any question related to this?
No, sir.
Okay. Uh, as I told you yesterday that after discussing this, I'll move to the differentiation from first principle. The first exercise in the first module was differentiation from first principles. And in fact, if you remember, I had told you how to differentiate x cube from first principles. I had shown you how to differentiate x cube from limits. Okay. Now we'll see all these problems, how they can be differentiated from limits. Okay. And you can check from your direct differentiation whether you are right or wrong. The ultimate answer that you get, you can check from your direct differentiation. Okay. Let's see. Let's start with the first one. Second one, in fact. Okay. Second one, the question is, because first one I've already done, let fx is equal to square root ax plus b, right? So therefore, what is x plus h? Fx plus h, it is square root of a into x plus h plus b, right? Which is equal to square root. Now you can multiply this throughout, you get ax plus h plus b, right? This is if x plus h. And what is the definition of dy dx? Call this y is equal to fx is equal to this. Therefore, dy dx is equal to f dash x. And from the definition, what is the definition of limit definition of differentiation? Limit h tends to 0, fx plus h minus fx divided by h. Okay. So you have limit h tends to 0. Now simply put the values first. Root over of ax plus h plus b minus root ax plus b divided by h. Now we cannot put h is equal to 0 because we have a denominator as h, which will become an indeterminate form. Therefore, we need to make some changes before we put h is equal to 0. What are the changes? We actually need to rationalize the numerator by multiplying by the rationalizing factor. So you multiply the numerator and denominator by the rationalizing factor. And what is the rationalizing factor in this case? It is root ax plus h plus b plus root ax plus b. This is the rationalizing factor. And rationalizing factor, we multiply the numerator and the denominator. So you have ax plus h plus b plus root ax plus b, right? So you get limit. Now the numerator is what form? A plus b into a minus b. So root over of ax plus h plus b whole square will simply give you ax plus h plus b. I hope this step is okay. I don't need to write an extra step, right?
Yes, sir.
Minus, and you have root ax plus b whole square, which is simply ax plus b divided by h root ax plus h plus b. Still, we haven't got a determinate form yet. So this is limit h tends to 0, ax plus h plus b minus ax minus b. If I open the brackets, divided by h root ax plus h plus b plus root ax plus b. Now, if you see here in the numerator, I think ax and ax is going to cancel, plus b and minus b is going to cancel. So you're only going to be left with limit h tends to 0, h divided by h into root ax plus h plus b plus root ax plus b. Okay. So here again h and h is going to cancel. Now can we put h is equal to 0? Yes. Now it will become a determinate form if I put h is equal to 0. So I get a by root over of ax plus a into 0 plus b plus root ax plus b. So this is 1 by root a by root ax plus b into a by root ax plus b, which will give you a by 2 root ax plus b. Now, if you want to check from normal differentiation whether you have got the right answer or not, what is the ddx of root ax plus b? Because dy dx is what? Dy dx is ddx root ax plus b. It is equal to ddx ax plus b to the power of half, isn't it? And how do you differentiate a ax plus b whole to the power of n? First, you have n into ax plus b to the power of n minus 1 into the coefficient of a, right? So you get here half ax, let's say a by 2, ax plus b to the power of minus half, right? And this you can write as a by twice ax plus b to the power of half, which is a by 2 root ax plus b. Have I got the right answer? Have I got the right answer?
Yes, sir.
Yes. So this is how you will check whether you have got, if you are differentiating from first principles, you can check from your normal differentiation whether you have got the right answer or not. If you have not, then perhaps you have made some mistake in the evaluation of the limit. Okay, let's do one more problem and finish this session. 3. Let y is equal to fx is equal to x to the power of minus 3 by 2. Now this is very similar to x cube, this differentiation, except that you have a fractional power. So no problem. We'll deal with the fractional power in a very similar manner. So fx plus h will be equal to x plus h to the power of minus 3 by 2, right? So therefore dy dx will be equal to f dash x. Write the definition first. Limit h tends to 0. Fx plus h minus fx whole divided by h. Okay. This is equal to limit h tends to 0. Fx plus h is x plus h to the power of minus 3 by 2. Minus fx is x to the power of minus 3 by 2 divided by h. an indeterminate form. Okay, so we'll convert this first to a determinate form. So what we are going to do is you're going to write this as a positive power first. In the numerator, you can write this as 1 by x plus h to the power of 3 by 2 minus 1 by x to the power of 3 by 2 whole divided by h. Now you take the LCM in the numerator. Limit h tends to 0. Take the LCM. You get x to the power of 3 by 2 into x plus h to the power of 3 by 2. So that you get x to the power of 3 by 2 minus x plus h to the power of 3 by 2. And this entire thing must be divided by h, right? Okay, so in the next step, what you can do is write this as limit h tends to 0, x to the power of 3 by 2 minus x plus h to the power of 3 by 2 divided by h into x to the power of 3 by 2 x plus h to the power of 3 by 2, right? Now, see, if you remember from your chapter on indices, fractional power x to the power of 3 by 2 can be written as root over of x cube, right? X cube to the power of half uh, means root x cube, right? Right or wrong?
Yes, sir.
Can be written as root x plus h cube, right? Divided by h into x to the power of 3 by 2 into x plus h to the power of 3 by 2. So now if you see in the numerator, you have radical. So you multiply this by the rationalizing factor. Limit h tends to 0. You have root x cube minus root x plus h whole cube into root x cube plus root x plus h whole cube divided by h into x to the power of 3 by 2 into x plus h to the power of 3 by 2 into um, root x cube plus root x plus h cube, right? Now in the numerator, you have a plus b into a minus b form. So root x cube whole square means simply x cube, right? And root x plus h whole cube square means x plus h whole cube, right? I can write this safely. I can remove the radical.
Yes, sir.
So I have left here h x to the power of 3 by 2, x plus h to the power of 3 by 2, and you have root x cube plus root x plus h whole cube, right? So now what we are going to do is the numerator we are going to expand by e plus b whole cube formula. You have x cube minus, you get here a cube plus b cube plus thrice a square b plus thrice a b square divided by h x to the power of 3 by 2 x plus h to the power of 3 by 2 into square root x cube plus square root x plus h whole cube, right? So now if you see, if I open the bracket here in the numerator, we are going to get x cube minus h cube minus thrice x square h minus thrice x h square divided by h x to the power of 3 by 2 into x plus h to the power of 3 by 2 into square root x cube plus square root x plus h whole cube, right? Now from the numerator you can cancel x cube and x cube, and also you see you have a h cube x square h and x h square from which you can take h common, right? So if I take h common, let's take minus h common. So I'm going to get h square plus thrice x square plus thrice xh divided by h into x to the power of 3 by 2 into x plus h to the power of 3 by 2 into square root x cube plus square root x plus h whole cube, right? So now from here, h and h is going to cancel. Now once h cancels from the denominator, now it seems that we are going to get some determinate form. So if you put h is equal to 0 here, what are we going to get? Minus 0 square plus 3x square plus 3x into 0 divided by x to the power of 3 by 2 into x plus 0 to the power of 3 by 2 into square root x cube plus square root x plus 0 whole cube, right? So that means now we get here minus 3x square simply in the numerator, right? And in the denominator, we are going to get x to the power of 3 by 2, right? Into x to the power of 3 by 2, x plus 0 to the power of 3 by 2 means x to the power of 3 by 2. And also you're going to get, sorry, this should be a bracket here, x to the power of 3 by 2 into x to the power of 3 by 2 into, this should be a bracket here, root x cube plus root x cube, right? So we are going to get here minus 3x square divided by x to the power of 3 by 2 plus x to the power of 3 by 2. You can add the powers, and this can be written as twice root x cube, right? So you're getting here minus 3x square divided by x to the power of 3 by 2 plus x to the power of 3 by 2 will give you x to the power of 6 by 2, which is x cube, and you have a 2. And root x cube, you can write this back as a fractional power, x to the power of 3 by 2. So what you see here is that x square and 1x will cancel here. So I get minus 3 by 2 into x to the power of 3 by 2, right? So I get minus 3 by 2 into x to the power of, now if you add the powers 1 plus 3 by 2, you get 5 by 2. So you get minus 3 by 2 x to the power of minus 5 by 2. This is your answer. And you can check this from your differentiation also. X to the power of n formula from differentiation, you can check this. Okay. I'll stop here then.